Hey everybody, and thank you for joining us for today's Digital Making at Home live stream. If you haven't already had a chance, say hello to us in the chat. Let us know where you're tuning in from. I'm Mr. C. I'm coming to you live from Cambridge in the UK, and back once again with us is the vivacious Christina. How are you, Christina?
Hello. I'm good. How about you, Mr. C?
Yeah, pretty good. I'm not used to this coldness, right? Still, I've lived here many years, but being Australian just gets to my bones. It's always...
For sure. It's cold here too. I'm joining from Nebraska in the US, and thank you to everyone who are joining us from your homes all over the world. Today is going to be great. Hello to Cora, Andrew. Hello to Simon in the Netherlands. Andrew saying thanks from Nigeria, from York. Duncan, thanks so much for joining. Today's, like I said, it's going to be great. We have two awesome things happening today. First, we're speaking with Gabriel, an incredible young maker who is into a lot of the same things actually as you, Mr. C, lasers, making, and robots. And then two, we're going to be doing some more beginner work with the Raspberry Pi Pico. We had such a blast exploring with Evan last week, and we know folks are excited about the newest addition to the Raspberry Pi family. Lasers and Pico, what a Wednesday adventure, right?
Yeah. Oh, I'm super excited for it. I can't wait to bring him on and ask him some questions about some of the crazy makes I've seen on his YouTube channel, especially like the laser baby. Don't try this at home, guys. Like, incredible stuff.
Okay, yeah, we're going to have to ask him questions about the laser baby. And we already have lots of people in the chat early. Again, like, oh, so awesome to see folks. Hello to Thomas from South Carolina, USA. Aisha on Facebook from Tunisia. Aloha from New Hampshire. Amy, hello, welcome. Thanks so much for joining us. We're excited to have you all.
Yeah, from everywhere. And if all those people who are here for the first time, welcome. Thanks for coming along. Here at Digital Making at Home, we're all about getting young people coding, creating, making amazing things with technology. And every week we talk with cool people like Gabriel. We hang out together, do things with code, like on the Pico, and we see amazing digital making projects from all over the world. We love chatting with you guys every Wednesday. We broadcast live to YouTube, Facebook, Twitter, and Twitch each week. We can see your comments in the chat on any of those platforms, and we do want to hear from you. So feel free to join in and ask questions, make suggestions, or just give us your opinion in the chat. Make sure to like and subscribe as well, or head to rpf.io/sub to get our content as it comes out.
Yes, subscribe. Just a reminder that while we don't do as many gadget videos as the Raspberry Pi Computers channel, the Raspberry Pi Foundation channel focuses more on getting young people making amazing things and empowering themselves with technology. You'll find great tutorials for our global community of young people, educators, and makers right here with all the product news on our other channel as always.
Absolutely, and shout outs to Pat, Paul, and Ranjit, some of our most recent subscribers. Thanks for being the newest members of Team Raspberry Pi. So should we get Gabriel on now and have a chat with him about all his robots, lasers, and the hazards of direct radiation?
Yes, come on, Gabriel, I got questions.
Hello.
Hey.
Hi, how are you doing, Gabriel?
Hi. Fine, thank you. Yeah.
Where are you joining us from?
I'm from Inverness, Scotland.
Yes. Okay, we've got 3 countries today. We've got USA, UK, and Scotland. Oh, amazing. Yes, winning.
Yeah. That's cool. So it's great if you come along today, man. Like, I've seen some of the amazing videos you've got on your YouTube channel. They blew my mind when I saw them. I was laughing out loud in a couple, like Laser Baby. We'll get to that, just blew my mind. I laughed my head off. Like, how did you first get into doing this wild sort of stuff? And what was your first project that you really sort of picked up and ran with it all the way to a point where you thought that is a cool thing?
Yeah, well, I first started getting electronics about 3 years ago. So I was doing science in my school, and we were doing about, I think, electromagnets, and just something about it really clicked. And I just thought to myself, yo, I have to know more. So I asked my mum for electronics kits on Amazon, and then just kind of slowly progressed to where I am now. The first project I did was probably like a little robot that was made out of matchsticks that you could control with potentiometers that like moved little servos.
Amazing, man. That's an advanced project for a first go. Like, that's pretty cool.
Well, yeah. that was what I would say was my first project, but obviously I did like kind of goof around with sensors and other things.
Yeah, and I love what you said, where it just clicked for you, right? And you continued to pursue that interest. You're like, I've got to know more, and that's such an incredible feeling. And it's amazing that your mom was like super supportive of that and got you those kits so you could get started. Now, let's talk into like the lasers, right? I have a lot of questions about the lasers. So you're making robots. Like, tell us a little bit about like how did you start incorporating lasers into those projects?
So I mean, a bunch of the kits had like small 5-volt lasers in them. So I mean, you're always fascinated. I don't know anybody that doesn't like lasers. So you always want to put them in your projects. But about, I don't know, a year and a half ago, I saw people on YouTube with much more powerful lasers, and I thought that's really cool. And I realized that actually from electronics, I had the skill set to safely carry out making things with lasers. So I spent about 6 months making my first laser gun, and then I've just been making things with really powerful lasers for the past year.
Amazing, man. That's really cool. And like you say, like it's a big thing about safety, right? Like I understand like there's some projects you've got, excuse me, like Laser Baby, which when I saw it, my first thought was that's off the wall, like that's crazy dangerous, right? So having a look at it now, you can see it in the background. It's diabolical, right? This Laser Baby is popping balloons with the lasers. See Gabriel gets
coming out of the eyes.
Awesome. So that's so cool. But like, what safety stuff would you do when you're working there? Like, you're not standing in your bedroom just pointing like high levels of like, laser around, right? Like, what is it that you're doing to make sure that you're not going to burn your eyes out?
So I said in one of my videos, but basically, I first close all the windows, close all the doors, tell everybody, don't come in my room, I'm going to be messing around with lasers. I then, secondly, what I do is I get a small red laser pointer and then just shine it around my room where I'm about to fire it, just to see for any reflective surfaces that might shine back. And then I obviously have very good laser goggles that will save my eyes from a direct hit. They're very professional, high standard, and also they're I never go in front of a laser, if you know what I mean. I never, I'm always facing parallel to where I'm shooting the laser. So, and if you just kind of do those rules, and I think the main thing is to not be too comfortable around it, because once you be too comfortable, you can slip up and there goes your eye.
Yeah, that's great.
Yeah, that makes me think a lot of, I used to teach science. And so safety was such a big part of the science classroom and doing labs. And you can have so much fun in the science classroom. You can have so much fun with lasers. And I really appreciate, Gabriel, you talking about just like the safety and like, you never want to be too comfortable. Now, I know there's another project, like for our Star Wars fans out there, you also made a lightsaber. Oh, there it is. So cool. Tell us a little about this one.
So, when did I make this? About a year ago-ish. I was just sitting around, and I came up with the idea of, what if I had 4 lasers, or that just spun around, and basically, due to a phenomena called persistence of vision, the 4 lasers kind of merged together into a kind of beam. So you can see the 4 lasers there. So it kind of made an illusion that there's a solid beam. Yeah. And I put it on a type of like retractable aerial thing, so I could extend it and close it.
Yeah, and I saw those goggles initially at the beginning. You had those cool safety laser goggles. And that cool. Looks really neat.
Did you need to experiment much with the speed that you rotate the lasers at in order to maintain that persistence of vision effect? Because it's the same thing that works on cartoons, right? If it goes too slow, then you notice that difference in the motion. Did you have to do a lot of revisions?
Yeah, well, I have on the box I showed in my video that I have a step-down converter that I could vary the voltage going to the motor, so I could vary the speed. Really, cool. At a certain point, it just becomes a solid beam. You can't tell that it's individual lasers.
Super cool. And you built a Van de Graaff generator as well, right? Like, which is a really cool thing to have built. Like, do you want to explain to the people who are watching what that is? Because I was amazed when I heard you built one of those. I was like, that is a cool thing to have built. I wish I built one.
Yeah. So a Van de Graaff generator, it's basically creates static electricity on a point. So it basically, how mine worked is it rotated a rubber belt across a PVC pipe, and then some brushes on the PVC pipe picked up the electrons and then kind of deposited them on a kind of orb. The orb was so the electrons don't run off. So you have all these electrons in the orb, and if you touch it, since there's a potential difference between yourself and the orb thing, there will be a spark that will ionize the air and cause like a little lightning.
So cool. You know when you're at school and you rubbed your feet on the carpet and then touch people? It's that.
Yeah, that's
like
exactly it.
Yeah.
So for folks at home, Gabriel made that.
Yeah, that's so
Made
cool.
his own.
I love that. I've seen really huge ones, right? When you see the big ones that are like good, like 10, 12 feet tall, and people will like arc them up, and you can stand like meters away and you'll get an arc jump to things and stuff. That's incredible to watch. It's so cool that you built that thing, man.
Yeah, and what's cool about it is that like you get to feel like a wizard, but it's also really safe. You can do it relatively safely, so that's always a good bonus.
Yes, that's a great feeling to feel like a wizard daily. I love that so much.
It's so cool, man. And it's like, I love all the gadgetry and the bits and pieces that you do in it. Like, it reminds me of James Bond. Like, especially you've got a laser watch, right? Like, you built yourself a James Bond laser watch. Yeah. Do you want to have a chat about that for the audience? I think they'll find that pretty cool.
Yeah, so basically using an Arduino, a OLED screen, some other bits like a battery, a BMS, which kind of charges the battery safely, and some bits like LED buttons and a laser. I was able to make this a watch that was like made out of little boxes, and and between the boxes were hinges so it could rotate, so you could put it on your wrist. But had a couple of flaws. Like, you can see the edges of the boxes; they're really very precise, and they're really at 90 degrees. So what ended up happening is they would scratch me a lot. So I would, if I wore it for any amount of time, I would end up with loads of scratches on my wrist.
Oh no! Oh, there it is on the wrist. Oh wow, that definitely looks very James Bond-esque.
Pretty chunky. You revised it since then, though, right? Like, since then you went away and you've changed the design, and now it's is that Mark II, Mark III?
Wait, is it on your wrist? Hold it up! Hold it up! Oh, so cool. Oh, that looks great. I see softer edges. Nice.
Softer edges. Awesome. Obviously a full color screen. And this was made with a ESP32, so I can control things through Wi-Fi or Bluetooth, which I think is really cool, because I could say have a light in my house that I could turn on remotely, so I wouldn't even need to get up. So, and also there's let me just get it up, another LED.
Oh,
super impressive.
That's so bright, yeah. Cool.
Laser.
And a red laser pointer.
Oh,
amazing, man.
So cool. I feel like as a kid, I like really wanted one. I want one now as an adult. That's really, Gabriel, thank you so much. Like, it's so cool to hear about your projects and just you being honest about the fact, like, there's an iteration process. Like, there are lots of revisions and you learn from it, right? Like, what you have on your wrist was not what you started with. So I think for me, it's a really good reminder that, like, have an idea, create a project and learn from it, right? And continue to make something super cool. It's been really awesome.
Absolutely. Thanks very much for coming on, man. And hopefully we'll catch up with you in the future.
See you later. Thanks, Gabriel.
Awesome, man.
Bye.
See you later. Oh, so good. I would love some lasers like that to play with at my house. Like, I would set up, you know how you see in the heist movies, they have those laser nets for like security that you have to like sneak through. Yeah. But so you'd set up with like LDRs pointing at a laser, and it would catch it and detect if you'd broken it. But with his lasers, you'd probably like feel it zap you if it touched you, right? Like,
right. Yeah. Wait. Oh, yes. So many thoughts there. I'm just thinking about that in the movie. What is an LDR? You mentioned that.
Oh, it's a light-dependent resistor, like a photoresistor. So it detects light with a small panel on top. There we go.
Okay.
And just like the variable resistor that we used with Eben on the Pico last week, this one will change resistance based on how much light it can detect against its little panel. And here's one in the flesh. I've got one here. It's about that size, the one I've got.
Nice. Okay, so you'd set it up so the lasers each pointed at a bunch of LDRs connected to the Pico. And if the Pi suddenly detects a big change in resistance in one of those, then you know the beam wasn't hitting the panel anymore, so you must have been in the way.
Exactly. Yeah, spot on. And then I'd make it play like a sad wah wah noise once it's at me, so that we can, and yeah, just like for a bit of fun. But yeah, that's the principle, like exactly that. So I mean, we can crack on with coding our new microcontroller, shall we?
Yes, let's do it. What do folks need at home to get started?
So, if you've got a Pico, you'll need one of those, so a little Raspberry Pi Pico. As we go on, you'll also need a USB, micro USB cable. And then as we go on, you can use a little bit of components. So we're using a breadboard, a resistor, an LED, and some male-to-male jumper cables today. All the instructions we are using are at ipf.io/pico-go, and I'm going to go really nice and slowly and explain everything that's going on for the people at home. Remember, you can all pause and rewind the video while we're working if you need a little bit more time. And there's that URL there, rpf.io/pico-go, exactly what we're going to be working on today. Ready to go?
Yes, let's do it. I'm excited.
Awesome. Okay, so the first thing you need to do is take your Raspberry Pi Pico, and we're assuming that you have Thonny installed on your machine already. So that's what we use as our coding interface. We're not going to go through today how to install Thonny on your laptop and stuff like that, but I will show you once you've got it going how to connect your Pico. So grab your Pico, and you'll see on the top there's this little white button, the boot cell button. Okay, so you can see it here. It's a little white button that says boot cell next to it. And so what we do is we hold that down. I connect it to my micro USB cable, and then I plug that into my laptop, and that will then connect it to Thonny, which is my coding interface. So we'll just pop that up on screen here now. You can see my Thonny. And so I've connected my Raspberry Pi Pico, and what I'll do is I'll open a file window for you so you can see. All right, so you can see just here, this is what all the drives connected to my laptop right now. OSC is where I keep all my files and things. It's probably the same on yours. But as I hold down boot cell and I connect my Pico, you'll see it adds a new drive to my computer called RPI RP2, and that is my Pico. So inside there, it's got a bunch of files. All right, here we go. And those files there allow me to put the interpreter that I need into Thonny. So if I let go now and go back into my Thonny, I should be able to, hang on a sec, let's get rid of that. That's a bit annoying.
All right, I'm seeing a request to get the link back up. We're at RPF, or we're using the resources at rpf.io/pico-go. And we'll put that in the chat as well, so you have it.
Cool. And so you see down here in the bottom, I just clicked where it says Python, and I've got MicroPython Raspberry Pi Pico. So I select that, and it asks me, do I want to install the firmware for Raspberry Pi? And I say, yep, I definitely do. That means I'll be able to run my Pico with the code I write today. Installing. Takes a couple of seconds, no time at all, because they're very small files, and then we're done and closed. And now we're running MicroPython for the Raspberry Pi Pico. Cool.
All right.
Easy
Nice
peasy,
work.
right? So now that we're connected, we've got the Pico, and it's hooked up to my Thonny here on the screen, and so I can type things into the console. Hang on a sec, I'll restart the REPL. There we go. And so you can see my console is down here. So what I can do is I can type stuff into here, and it will work just like it would if I was running a computer. So it's using the Pico, using the shell here to control the Pico and get it to do stuff. So that's really cool now. So I can start running code and actually running it through my Pico as though it would to prototype. And then once I've done that, I can put the code on the machine and then disconnect it from my computer. I connect it up to a battery and run it wherever I want. It will just code. And so how far if you got it all so far, Christina, it's all pretty straightforward?
Yes, got it so far. So now that we've got this set up, what are we going to try and control on the Pico?
Right, so on the Pico itself, there's like a little green LED on the top, okay? So it's hard to see on the camera, I'll put it up here, but there's a little green LED that's just on the top, and we're gonna light that up. So we're gonna use some code here in the console now. I'm gonna type a line at a time and hit enter, and it's just like writing a script if you're writing a whole program, but instead of writing it all at once, we're just gonna write it a line at a time and get it to do the thing that we want. So the first line that we need to do is we're going to go from machine import pin. And so that's going out and bringing in our modules. Yeah, we've talked about them in the past. It's kind of like if I asked you to go and find the reciprocating dingle arm made of prefamulated amulite in the workshop, without a description of what that was, that's jargon to you, right? That's total gibberish. But if I gave you a definition of the thing I've just said, a book that you can look up the answer and understand what that was, then you could come back and go, oh, cool, yeah, I know what you mean here. And it's the same here. We're going to say to the Pico, I'm going to throw some stuff at you about a pin, which is the LED we're going to light up. And if you don't go and get the book full of definitions, you'll have no idea what I'm talking about. So having typed this in, I can push enter, and it goes and gets those modules for me. It's now ready for me to talk to it about pin.
That's one of my favorite explanation of modules I've ever heard, by the way. That's solid.
So what we do now is I need to tell it that when I talk to you about the pin that I'm going to turn on and off, you need to know what I mean. So I'm going to set that up, and I'm going to say, this is the LED I'm going to blink. So I'm going to say the LED, this is my variable called LED. So when I call LED all through my code, it's going to refer to what I type now. And I say 25, because that's the pin that the LED is on.
Okay. I was going to ask that. Why 25? Because you can usually pick which one number you want, but we have to pick 25.
Yeah, we do, because this is specifically the onboard LED. And so pin 25 is the one that controls that.
Got it.
So we say pin out.
What does out mean?
Okay, so pins can be in or out. And so this, we're setting that up to push power, to push information as opposed to receive or detect information. This is now an out pin. So when I hit enter, I've now set pin 25 to out. So it now knows that when I tell it to do something, that's what I mean. I'm talking about the out pin number 25 every time I say LED. And then I tell LED.value 1. And then go like this. And when I hit enter, my LED.
Oh, can I see it? Oh, I see it.
Oh, it's glowing.
Nice.
Okay. Cool. And then so I've just turned the LED on by using that line of code in the console. And I can do the same thing. I can turn it off as well. It's quite an easy thing to turn it off in exactly the same way. So I just, I'd have to type the same line, but instead of 1, I put 0, right? And so to bring that line back for everybody at home, work smarter, not harder. You just push up in the console and it will bring back the last thing you typed. So LED.value.
Pro tip.
Right, pro tip, 0. And then you see my LED is on and shining. And then when I hit enter, off it goes. All right. So that's
nice work. That was really simple and a really great way to just get started with the Pico. And I noticed in here that we could either have the output pin be either 1 or 0. And that's why we call them digital, right? They only have 2 settings, right? Exactly. So 0 turned off the power, and that's a bit like a light switch in the house. So for folks at home, it can either be on or off, and for us, 1 or 0.
Yep, and that value works in lots of different ways too. So you can say true is also 1, right? You can set the value true, and that means 1 as well. There's lots of different ways to use it. And then what we were working with Eben, where we had that variable resistor, the potentiometer last week, that works in analog because it has numbers between 0 and 1 that it can detect or it can put out. So that's an analog control. That's quite
different. It's like a dimmer switch, right?
Exactly that, yeah. So the 1, 0, that's digital, and that's what we're going to be doing today. And what we did last week with Eben, the advanced bit, that was analog. That was like fancy pants stuff.
Fancy pants.
So what we want to do now is we want to do something a bit different with it, in the sense that I'm going to write a program that we're going to put on the Pico, and then every time I click run, it will run my program on the Pico. And so what I'm going to do is I'm going to get it to turn the light on and off as we run the code. Okay. So I run the code once, the light will come on. I run the code again, the light will go off.
Okay.
Right.
All right. Let's see that.
So to do that, we write up here. So I was down in the bottom part in the console, but now we're moving up here into the scripting window where we write stuff. Okay. And so, I mean, I can kind of cheat because, again, smarter, not harder. Control-C, Control-V, get rid of these chevrons.
Also, while you're doing that, I just want to say thanks so much to Eddie's Tech on YouTube, saying congrats on our 2,000 subscribers. Thank you, Eddie's Tech. And Eddie mentioned, did we get some of those donuts we wanted from the head of communications? Not yet. I'll definitely be reaching out to the communications team. but yeah, make sure, folks, to subscribe. You'll get alerts when we go live. You'll get to check out all past content. Head over to rpf.io/subscribe and join the fun.
Yeah, because it's nice to watch the videos later on playback, but it's way better to be here with us while we're doing it. And we can talk to you. You can ask us questions, chat with us, all that sort of stuff. Let us know how it's going. But yeah, so I've only got one line of code to type because we've worked smarter, not harder, and copied the rest. So the last part is really easy because now I've called the LED. I just tell it that I want a toggle, which is exactly what you think it is. It's like an on, off, on, off. Yeah, right. So that's it. So I want to run this script now. So instead of just hitting enter where it ran automatically for me, I come up here to the little green run button and I run my code. And it asks me, do you want to run it on this computer or the Pico? So I'm still connected. So right now I'm just going to run it straight on the computer here. I'm going to choose this computer. But if I wanted to disconnect, which we'll do in a minute with our more complicated one, I would use the Pico option. So you'll see here, I'm going to run it on this computer.
Let's see, moment of truth.
Oh, it wants me to save my code anyway. That's
gotta
fine.
Save it. Always gotta save it. That moment, right when you're about to run your program, and then you gotta save it.
See, but that's the thing. It reminds me every time, because I'm the worst for that, for losing work because I haven't saved it or running a thing. I'm glad it did that for me, right? That's my fail safe. I'm glad it did that. So yeah, so blink, fantastic. And we can see it's on. And now I can run my code again, and it will go off and on and off and on and off and on and off. On, off, on, off, on, off, on, off.
And you're having to keep clicking this, right? Yes.
yeah. Every time I run the code, it toggles my light now. And so we could do something different with that. We could set it up to run on the MicroPython. Like we could run it as a blink loop. So I could just take this LED toggle and I could give it the while true.
Mm-hmm. Okay. This is like a forever loop. So if you're familiar with Scratch, this is the forever loop. That's what we're adding in here.
Absolutely, yeah, that's exactly right. Okay, so I've got while true LED.toggle, and then I'd want sleep 0.1. But remembering that the Pico doesn't know what I'm talking about when I say sleep, so I need to go up and tell it, go get the book about time that contains a chapter called sleep. Okay, go get that for me. And he'll head off and get that and come back with my sleep so that when I run my code on the computer, it should just blink my light at a 1/10 of a second interval.
Fingers crossed. There it is.
And so if I change this number here in my code, so I change my little sleep timer, I'll change that to 0.5 because that's a nice difference. And then I'll run my code and you'll see the light will start blinking slower. Okay, lots of control over that light. Cool, right? And that's just that's just pin 25. So that's the onboard LED. So if you own a Pico, then you can get this far. That's no problem. But shall we do some physical stuff like real world out here, proper light bulb on my desk stuff?
Yes. And let's also take a moment to just appreciate it worked. Like as few of those lines as it was, like, right? And I think for folks at home, we have a blast, but it's always a little bit nerve-wracking to do live coding. So make sure, send Mr. C some love. Like we got it. So we got it.
I don't know if you can tell. I do get tense when I'm coding because I'm like, oh, like everybody is watching me type typos.
I know. Don't mess up. Spell true correctly. Where's the capital T?
All that. Like, yeah, it's always a bit stressful, but that's cool. Thanks, Christina. I feel much better about it now. It's nice tension break.
Of course. It's gotta appreciate it. It's the small wins, right? And that's what leads us to the laser babies, right? That's what leads us to the lightsabers. It's just these small wins where you get it. And you have to celebrate that. It's so important.
Totally, exactly right. And so moving on now, we get your physical components together, everybody. If you have some at home, like you can get the edu kits or even just the most basic components. We really need just a breadboard, a resistor, an LED, and some jumper cables and a Pico, and we're off for this one. And so what we want to do is we've got a little circuit diagram. So I'll show you what that is, and I'll wire that up here. So you can see this all here. That's our circuit diagram. So I'm going to pop that together. Have you got any questions about that picture there, Christina? Does that all make sense to you, what that is? You can see our bits and pieces.
I don't. I think it's actually a really great diagram. But how about explain it for folks at home, right? And it's definitely like we can point out. We see our Pico, we see our LED, we see our resistor. And let us know if you have questions at home for sure. Like this is for you, right? So you can learn about how to use the Pico, how to, like what Mr. C says. Now we're doing some physical computing. So let us know if you have any questions.
Yeah, cool. So that picture there is showing you that what you can do is if you've got your breadboard, and you'll see that along one side, the breadboard itself is numbered, right? So you've got rows that are numbered 1, 5, 10, 15, 20 along both rails there. We've got the Pico just pushed straight across the spine of your breadboard or the ravine or the gap or the whatever you want to call it in the middle. I know everybody I talk to has a different name.
The channel, the abyss.
Yeah, all those things, right? And then so you can see off the corner there, that bottom right corner of our Pico, that's the last pin. And you can see that they're all lit by yellow because they're connected to pins, right? That's telling us that these things are live. And we've got a little resistor that pops off the corner. So that picture there is of a resistor, and you can use any really low resistance one, like 100, 300, doesn't really matter. The difference will just be the brightness of your LED. And then we go jump across there. You can see we follow the little yellow line along to the leg of the LED. We can see it pops up and into the LED, down the LED, follows along to that black line, which connects back to our earth rail. And so now we've made a full circuit and we can run power through it and it will all work. And so I've wired that up here. I've got my little circuit here, nice and wired up while I've been chatting.
Oh, nice. All right. And remember, folks, the LED or the resistor is a super important part of this. LEDs, they're little and they're delicate. And so I've definitely, shout out to Heidi who showed me you could put the LED straight on your power supply, but that's a bad idea. You want to have the resistor in there. So that's a really important part of this. So you don't burn out your LEDs and run out of supplies.
Absolutely, yeah. I mean, these big chunky LEDs that I use, they're very, very tolerant. And so if you don't have resistors, don't be too afraid. I mean, at the end of the day, LED is an LED and you can probably get another one for not too much. But yes, so the ones that you use, I get really nice, stable, huge, big, chunky ones. Like you can see how big my LED is on there. So for teachers or anybody watching, if you get the bigger, heavy, chunky, like 5 milli ones here and bigger, they're nice and stable and they can handle a bit more chunky current. So what we're going to do now is we've got the whole thing set up this way to toggle our light on board the Pico. But now we want it to do one that's external to the Pico. And so all we really need to do with the whole thing is change a few little lines of the code. So that pin that we're connected to is pin 15. And so we just change, instead of pin 25, I want it to be pin 15, okay, because that's our output pin now. It's still an output pin, exactly what I want it to be. I've got my from time import sleep because I want to do the loop. The only thing I don't want it to do here is... Well, I suppose I could leave it like that, actually. It'd work exactly that way. And so it's just going to keep flicking that circuit for me on a new pin. And it should, if I save my code now and run it. Okay, so I've literally just changed same code. The only thing I really changed was the pin number, and that's it.
Woo-hoo! That's great. Nice work. Oh, I love how simple it was just to switch between the two, but how big of an impact it makes. Like, I think this is, like you mentioned, yeah, for teachers, being able to have this, like it all starts with an LED. It's that's really awesome. Now I have a quick question for 15. Could it be anyone, or is it only a specific pin? Could you choose to have it connected to any?
So you need, well, it could be any pin. I'm using this pin because it's easy peasy for me to get to that corner. Like we're looking at it, it's that corner. The corner is accessible to you, and that's pin 15. But you can connect it up to any GP numbered pin, and it will work totally fine. It's just a matter of putting that number in your code. So you can see I've added an extra line here with LED 1. And so if I add another line here for LED 1 toggle, and I run my code there, I should get both the lights are now blinking on my Pico.
I see it.
Okay. And so that's that code running there. And so now if I stop it and I say,
all right. Seeing a question on YouTube, I would like to program my Raspberry Pi Pico from my iPad instead of my laptop. Is that possible?
So at the moment, I think it's not possible because the interpreter that you require, I'm pretty sure you can't do it from your tablet at the moment. You can ask we've got Mark in the chat who's answering some of our technical questions, so I might refer that one to him, but I'm pretty sure you can't at this time. I'm afraid that's unfortunate. But yeah, we'll check back in on that question a bit later once we know what the answer is, just for the people at home as well.
Yeah, thanks for asking.
What I'm going to do now is I'd like to take that code off my laptop, because right now I still have to be connected to my laptop for it to work. And so I would like to be able to disconnect it from my laptop and simply connect it up to one of my little like portable telephone charger batteries. So any old battery pack will work. Like you've probably got one lying around to charge your phone. Anything will do. 5 volts, 1 amp should be totally fine. If it works on your phone, it will be totally safe for your Pico. And so we'll save the code this time to Raspberry Pi Pico instead of my computer. So we're going to run it on the Pico, and I'm going to call it main.py. I'm going to say, okay.
Is there a reason that you need to call it main.py?
Yeah, because the microcontroller, when it boots, it checks for a script called main.py to be the thing that it boot loads. And so you need to call your script main.py so that when it boots, it picks that up and it will do what you want it to do straight off. So you say yes, saves it. We get a little bit of an info window there.
So now we're removing, we're disconnecting from the computer and we're putting it into the power source.
Yeah, totally.
Exciting.
And then on comes the battery, and we got my whole code running.
Nice. Free.
Right,
Free
and so
for
that's totally embeddable now. Any code that I wanted to write on that, whether it was running motors or it was running whatever else, like I could just take that and it would be standalone. It would run on power and it would do the thing I asked it to do. It's a completely separate machine from my laptop. I've built a whole gadget.
That's amazing. Like
Right.
that was super helpful for me. I don't have my Pico yet, but I'm very excited to get one. So I'll be rewatching this video. And for folks at home, I hope, like, we really hope you enjoy just playing with the Pico with us. It's a lot of fun. And this I think was one of the best sort of like walkthroughs that I've seen. It was really helpful. And I appreciate your explanation, Mr. C.
Oh, it's my pleasure. I mean, being able to program a little board like Pico for embedding using Thonny, like you saw, it's like really, really easy. And it means that I can make all sorts of cool stuff. Like one of the things that I'm thinking about right now is making a physical game controller. So I could take a Pico, I could embed it, I could have it have all these sort of like switches and detectors on it so that I could actually make a game controller that you could shake, or you would have to bang things together in order to control my game.
I love that. That's really cool. And let us know how it goes. Like I definitely want to see it. Hopefully see it in person one day.
Yeah.
And if you end up making something awesome with your Pico, you could enter it into Coolest Projects. Coolest Projects is one of our amazing programs where young people around the world can showcase what they've created with code. So idea registration actually just launched this week. So check out coolestprojects.org, right there, the link for more information. Now, it was so great to see so many of you getting involved this week in the chat with your questions. Shout out there are some names here I on YouTube to Sibulks. I hope I'm pronouncing it correctly. Eddie's Tech, Andrew. Thank you all so much for joining us and for connecting with us. It's so great. Catherine Childs, I want to shout you out. You mentioned live coding is awesome. Agree with you. Thank you so much for joining us. And thank you to Gabriel for joining and showing off his lasers and cool watch. So cool. Very James Bond. Yeah, that was really neat. We made a short link for his channel. You can check it out, rpf.io/Gabriel. Go and subscribe and see more of his awesome content.
Amazing, yeah. And thanks again to our colleague Mark Scott, who's been in the chat fielding technical questions. If you didn't get your question answered today, there's tons of really high quality technical docs available at rpf.io/pico-docs. And if you still need a question answered, then you can check out the Raspberry Pi forum.
Yes. So that's all we have time for this week, but you can always get in touch with us. Send us an email at dmah@raspberrypi.org. Yes. And if you make something you want to share with us, tweet a picture of it to us at raspberry_pi. We'd love to see it.
Totally. And before you go, make sure to like and subscribe so that you'll be the first to know when we go live, and you'll get updates on all the other cool content on our channel as we bring it out. Remember, this is our new channel, which focuses on supporting young makers, coders, and inventors like you all around the world. So subscribe so you can be here live with us while we chat to you. So thanks you all for being here for the Raspberry Pi Foundation's Digital Making at Home live stream this week. We're back again next week, once again, with more digital making. Until then, stay safe and healthy, and we'll catch you next time. See you later.
Bye.
See you, Christina.